Good evening, guys.
Good evening, sir.
So, who is raising the questions yesterday about shear force of him? Good. So, who is the one yesterday? It's about the sign convention. Now, can you guys tell me what is the problem exactly for yesterday's sign convention for shear force diagram? Just to make you clarity, let me give you. And let us say I'm interested in center point. I need to find shear force at a point C. Let us say points I have considered at the midpoint. And at first, let us say there is a load 10 kilonewton. Let us say in first case, the load is at a distance of 1 meter from support A. And in second case, it is at 2 meter from support A, 3 meter from support A, 4 meter from support A, and 5 meter from support A. Can you guys quickly tell me what will be the shear force at point C in all these 5 cases? What is the shear force at point C? Quickly, can you guys find it out? What is the shear force at point C if load is at 1 meter from support A? And what is the shear force at C if the load is at 2 meter from support A? Just like the same for everybody, for each case. So in first case, if the load is somewhere here, 10 kilonewton, and if distance is 1 meter, can you guys tell me quickly what are the support reactions here? Reaction at A, 9 kilonewton, reaction at B, 1 kilonewton, right? What about the shear force at midpoint then, in this case? What is the shear force at point C? You can look into the right side or you can look into the left side. If I look into the right side, how many forces are there? 1 kilonewton. What is the sign convention? If there is, if you are looking from right side, if there is a force in upward direction, we have to consider it as a negative. So if I look into the right side, I am having only one force, that is 1 kilonewton. As it is upward, I can say my shear force at point C is minus 1 kilonewton. This is if I found out by from right side. In the same way, find out for looking into the left side. If you look into the left side, how many forces are there? 2. What is the sign convention? If you're looking from right side, if it is upward, you have to treat it as a negative. If you look into the left side, right side upward is negative, then left side upward is positive. So this is positive shear force and this is a negative shear force. So positive how much? Algebraic sum of these values, plus 9, minus 10. What is the value? Minus 1 kilonewton. It doesn't matter on which side you will look into, but you will get the same answer. But make sure that you will look into only one side. Similarly, in the same way, can you guys tell me what will be the shear force at C if your load is at 2 meter from point A? If the distance is at 1 meter, what about the reaction here? 1 meter. If the distance is 2 meter, can you tell me what is the reaction here?
Left side 8, right side
2, right? Then what is the shear force at point C? If you look into the right side, 1 force.
1, 2 kilometers.
Minus 2. Similarly, what about it at x equal to 3? What is the shear force? Can I say? Similarly, at x equal to 4, what about the value? Minus 4. What about here? If the load is at 5 meters from point A, what will be the shear force at point C? Why this case is different from the previous 4 cases? Can you guess it? Why? Why you guys are not so active today? What happened?
No idea, sir.
It's offline class.
No
I
idea.
could have brought you some snacks. Yesterday we have discussed. So where is our point C? Point C is exactly midpoint. And in the last case, where our load is acting? Our load is also acting at the
No.
same point, isn't it?
Yes, sir.
Wherever there is a shear force, wherever there is a load, then we cannot define the shear force exactly at that point. We have to define either to the left or to the right. In this case, what about the support reaction?
5,
5,
5,
5 kilonewton.
5 kilometer.
Okay. Now,
Yes, sir.
let me draw the shear force diagram. As you can see, right side upward. What is the shear force? Right side upward.
Right, left, right.
Minus.
Minus sign, sir.
As you can see, whenever there is a concentrated load acting at a joint or not at a joint, wherever there is a concentrated load, or if there is a concentrated load acting on the point where you are finding the shear force. Once again, if there is any concentrated force or the reaction acting at the point where we are finding the shear force, we cannot define exactly at that point mathematically, because left side limits and right side limits will be different. So wherever there is a concentrated force or the reaction acting at the point at which we are finding the shear force, we have to find just either to the right or just either to the left. These are all the mathematical terms. Like, we cannot define exactly at that point, but we can say that instead of defining at 5 meter, what I will say, I will define at 5 meter into 10 to the power of minus 100 meter. Literally, does it make any difference? If I say 10 to the power of minus 10, how much will get? Obviously, 99999, isn't it?
Yes, sir.
How much will get? 5 meter. Here is not the point of the distance, like 5 meter, or what is the distance exactly that we are telling just to the left or just to the right. But in a physical sense, we are saying that we are talking about just to the left of that section, just to the right of that section. That's it. But in the calculation, we will take 5 meters only. Why? Because as I told you, as we're talking about immediately to the left, we don't bother about the distances. But physically speaking, we don't find at that point. So this is the thumb rule that wherever the concentrated loads or reactive forces, then shear force can't be defined. As in this case, the point load or the load 10 kilonewton, if it is exactly acting at the point C, we cannot define. That's why we'll just define just to the left of it, just to the right of it. Now, as you can observe here, as long as the load 10 kilonewton is in between A to C, what is the shear force at point C? Are you getting it in a negative or positive? Because the load is here, after that, the load is here, the load is here, the load is here. If the load is in between A to C, what about the shear force at point C? Are you getting the negative value or positive value?
Positive, sir.
Again, how come positive we are getting here? As we have seen, right?
Left down, negative. Sorry, sir.
Negative, negative.
Yes, sir.
How you guys have remembered this left down negative? Have you
Left
guys
up, right down is positive, sir. So, and vice versa.
write down is positive?
Left
Right.
up, right down is positive. That's all. And vice versa is negative.
Follow this simply. Run. Why do we? There is no point of getting confusion here if you use this. Rights run, right side upward negative. Simply based on that, we can take the opposite directions. So if possible, try to remember like this. This is the, I think, best way to remember the sign convention. That's it.
Okay.
So as long as the load is in the portion A to C, at point C, we will have the negative shear force. If the load is exactly at point C, we cannot define because the load is directly acting at that point. In the same way, if the load moves to the right side, what will be the sign convention then? What will be the shear force at point C? Will it be positive or will it be negative?
Positive, sir.
Right. So just like in the same way, in this case diagram, if we are talking about shear force at point C, what is the first point that we have discussed? We have to release the force. If I'm talking about, let us say this is what your initial beam, let us say, and this is what the point you are talking about. At this point, internal forces will generate, isn't it? The internal forces may be the axial force, shear force, and then bending moment. But in the present case, we are interested in only for ILD for shear force. As we have discussed in the previous class, whatever the ILD you want to draw, you have to release that force only. As I am going to draw the ILD for shear force, I will release the force along the direction. So that's why in this case, what I did, I have just placed the vertical shear hinge. That means if I take a support like this in between, if I take this type of arrangement, that means only at this section the beams can move along the vertical direction. At the same time, it will not release the axial force. At the same time, it will not release the bending moment. As we have discussed, the left side part, I will move it with the downward direction. The right side part, I will move it with the upward direction. So if you move this in upward, obviously, as rotation at this point is allowed, how it is going to deflect like this. Similarly, at point A is also rotation is allowed. So the reflection is going to like this. And then this is what the internal point in the beam. That means at this point, the slope will be same. Slope of, let us say if this is C, if this is A and this is B, as that is the internal point, slope of CA will be equal to slope of CB. For that, you can check here. See, if I find the slope here, clockwise direction. If I find the slope here, again, it is in clockwise direction. So as it is the internal point in between the beam, we should not violate the bending moment at that point. There will be resisting forces generated. That means the rotations will be same. Here, if this is theta, this one is also with theta. If this is theta, from the opposite triangle, this is theta. And this is also a theta. So this is how we have to draw the shear force diagram. So how can I find out this theta then? Let us say if this is L by 2. What about this ordinate? Let us say if this is Y, then Y can be is equal to, if this is theta and the length is L by 2, what about the Y? Y can be written as theta into L by 2. And what about here? Let us say if this is X. What about the X value? X can be written as, again, L by 2 into, sorry, in this case, I have considered the same distance. Let us say instead of L by 2, let me consider this is this distance xy. No, let me change this xy. Or let me do one thing. If this is z, let me consider this is L minus z. So whatever the y value is nothing but a theta into z. What about x value? X value is nothing but a theta into L minus z. As we talk about, we have to apply the unit displacement. That means if we add x plus y is equal to 1, that means theta into z plus L minus z. If we add, L minus z into theta, if we add these quantities, you should get it as equal to 1. Clear? This is how, at least, is it clear how to draw the diagram? First of all, shear force diagram.
Shear force diagram, okay, sir.
Not shear force diagram, this ILD for shear force diagram.
Yes, sir. ILD for shear force diagram is clear.
Okay, then let us start with an example. Before moving on to discuss further, now, if I'm talking about a point C, if this distance is Z, then this distance will be L minus Z. And my ILD will be look like this. And as we know that, if I take the same point P in the initial configuration, so here the slope of the left, suppose if I'm talking about this is the point P, then I can say my slope at P towards A will be equal to slope at B towards B. This is what the rigid body, rigid joint, that's what we discussed in the previous slide. There is a rigid joint, the rotations of the corresponding members will be same. Just like in the same way, if you are talking about a point, the rotation will be defined by single point. That means rotation at point P. That means if you talk about rotation at P towards A, or if you talk about rotation at P towards B, the both will be same. That's why here this one will be theta and this one will also be theta. And this quantity is nothing but Z by L. That means if this distance is Z, this is Z by L, and this quantity is nothing but L minus Z by L. If we add these two quantities again, we have to get unit displacement L by Z by L plus Z by L. If we add this, we will get it as a 1. If this is Z by L, what about the slope here? Slope is nothing but a 1 by L. What about the slope here? So wherever you want to draw ILD for shear force diagram, first of all, release that force and then apply right side part to the upward direction, left side part to the downward direction, and then the rotations at the corresponding joints will be equal to 1 by L and 1 by L. Then whatever the ordinates on the left side, it is nothing but a Z by L. Ordinate on the upward is nothing but a L minus Z by L. Is it okay? This case about the ordinates and the slopes.
Sir, I have a doubt.
Yeah.
The second figure, theta towards PA equal to theta PB, would you please represent in the drawing, sir?
Yeah. And in this case, you want to represent in this diagram or you want to represent in this diagram? Am I audible?
Second. Yes, sir. Second. Sorry, I unmuted. Second diagram is okay, sir. Anything I should understand. That's it.
Let us see if there is a point load or any UDL load, how the deflected shape will be. Like this,
Okay.
isn't it?
Okay. Yes, sir.
If I'm talking about any arbitrary point,
Okay.
let us say this is some arbitrary point. You will say the slope at point P, isn't it?
Yes, sir.
If I separate it into two parts, like just for the imagination only. Here you can see, look into the only one point, that's why you can directly say P. If I separate that into two parts, then if this is the point P, again the point P, and this is, let us say this is support P. Same point we have considered to the left side part, same point we have considered on the right side part.
Okay, sir.
As literally, this is literally speaking, this is a single point, isn't it? This is theta
Yes, sir.
p. If you want to represent this slope, either in the left side part, if you want to represent in the right side part. In this case, if you want to represent, what you will say? You will say theta at p towards A, as we are treating this as some left side section. If you want to represent this point in this section, you will represent theta at p towards P. But literally speaking, these are in the original case, these are at the same point. If I draw a line here, if I represent the slope,
Yes, sir.
some theta p. It's just representing in a two different parts only, that's it.
Okay. In the same way, we are taking theta equal to 1 by L at this both support. Am I right, sir?
Yeah, here what I mean to say is that at this point, let us say this is theta, right?
Yes, sir.
According to our convention,
This is theta. Yes, sir.
theta and this theta, they both should be same, isn't it?
Yes, sir. Yes, sir. Yes, sir.
The continuity requirement should be same, just like here,
Yes, sir. Yes, sir.
as in the original diagram. So
Yes.
as it is a linear variation, if this is theta, then what about this angle? Opposite angles are always equal. So
Yes.
if this is theta, this is also theta. Like similarly, if this is theta, this is also theta.
Okay, sir. Clear.
Here, at least.
Clear, sir. Clear.
So in the same way, if we add these two ordinates, you should get equal to 1. And then some minor calculations, then you will get at the end, the slope here will be equal to 1 by L. The slope here will be equal to 1 by L. If this know the slope, then obviously this distance will be this distance Z by L. Again, this distance is L minus Z by L. That's it. Clear? At least got an idea about the slope.
Yes, sir.
So in the same way, let me draw you, or let us draw some shear force for 3 different cases. Let me take some point here, and let us say this is 5 meter and this is 5 meter. Again, the ideally for shear force at that point, see how it will look like. It will look like this. What about the slope here? What is the total length of this? 5 plus 5, 10. So what about the slope here? 1 divided by 10. What about the slope here? 1 divided by 10. What about this ordinate? Slope is 1 by 10. From here to here, what is the distance? 5 meters. So what is the distance? What is the ordinate? 5 divided by 10. 0.5. And here also how much you get it? 0.5. And if we add these two values, then again you are getting 1. Any doubt in this diagram?
No, sir. Clear.
These are just some rules that we can follow. That's it. Nothing else we can do. Can I know why you guys are so silent? Can you please tell me? Or if you guys are not interested, or if you are not understanding anything, let me know. I'll take class at some other time also, no issue. Or if you want me to explain any other thing, I am free to discuss, no issues. But as I can see, everybody is quiet today. So in the same way, can you draw the shear force at this point? Let us say C. Previously, we have considered C at exactly at the midpoint. Let us say if we have considered points at 2 meters from support A, how it will look like? This part will go in the upward direction. Left side part will go in the downward direction.
Yes.
And then I will simply join this two, and I will simply join this. What about this slope? Slope at the connected members?
Slope is same only.
1 by length. What is the length of the beam? Length of the beam I have changed. 1 by 10. What about the slope here? Again, 1 by 10. Can you tell me what about this ordinate?
Small triangle is 2 by 10, sir.
How much?
2 by 10.
2 by 10. Simply point to, right?
Yes, sir. 0.2 and that one is 0.8.
Okay. Really, if I'm considering it a left side 1 meter, how the deflected shape will be or how the ILD will be. Isn't it?
Yes, sir.
Slope will not change because length is not changing.
Length is yes.
Here also 1 by 10. Here the slope is also 1 by 10. And what about this ordinate?
0.1 and 0.9.
0.1 and 0.9.
0.9.
So below this beam, this is a negative shear force, positive, negative shear force, positive, negative shear force, positive shear force. Can you understand one thing from here?
Uh,
What can we
When-
understand in cases? Can we generalize
when
it?
the yes, sir. When the load is moving towards left, the positive shear force is increasing.
Here is here in all these cases, the point is different, isn't it?
Yes,
In the
sir.
first case, the point is at midpoint, and in the second case, the point is moved towards left. In the third case, the point is still further moved to the left. Here we are not given any load, isn't it? Here,
sir.
in these three cases, the point we have considered is changing. As the point, as we keep on moving it to the left side, what is happening?
Positive shear force is increasing.
Positive shear force is increasing and
Yes,
negative shear force
negative
is
shear force is
decreasing.
decreasing.
In the same way, if I consider or if I move the point to the right side, if I consider point here, if I consider the point somewhere here, if I consider the point somewhere here, what will happen then? If the point is slightly moved to the left side, what is happening?
Then negative shear force will increase.
Similarly, in the same logic, if the point is moved to the right side, what conclusion that we can give?
Okay.
Obviously, what is happening? If it moved to point considered to the right, what is happening? This distance is decreasing, isn't it?
Yes, sir. Yes, sir.
This distance is decreasing, then which quantity is decreasing? Positive.
Positive decreasing.
So if the point is moving towards the right, then positive shear force ordinate will decrease. If the point is shifted towards left, then negative shear force ordinate is decreasing, vice versa. Right?
Yes, sir.
Clear? Any doubt in the discussion?
Clear, sir.
Now, again the same thing, but I have considered the overhanging part. Again, here the distance is 5 meter and 5 meter. I have considered the point C. Now, again, if I want to draw ILD for shear force at point C, how it's going to look like? I will cut the section. Right side part I will move to the upward. Left side part I will move to the downward. This is what the deflected shape. What about to the overhanging part? How the
It will
deflected
move
part will,
upward, sir.
right? This point will not move anywhere. So obviously, what about this slope? 1 by 10. As total length is not changing. What about this slope? 1 by
Yes,
10.
also same 1 by 10.
0.5. This ordinate is not changing. This ordinate will also not change. Then what about this? What about this slope?
Same
Same is right? 1
same
by
only, sir. 1 by 10.
this is
Same
1 by 10.
slope.
This is also 1 by 10. What
Yes,
about
sir.
this ordinate then? Total distance is 3 meters. Slope is 1 by 10. What about this ordinate? 3 into 1 by 10. 0.3.
3.
Right? Similarly, if I consider a point C, that is 1 meter from the support. Now, how the diagram will look like? Let us say this is 9 meter in this case. How the diagram will look like in this case now? At this point, I will cut. The right side part I will move to the upward. Left side part I will move to the downward. I will join here. This is the case, isn't it again? Slope will not change. Why? Because again, 1 by 10. And here also the slope will not change. How much? 1 by 10. What about this magnitude? 0.1. What about this magnitude? 0.9. What about this slope then? If this is 1 by 10, what about this slope?
That's also same 1 by 10.
1 by 10. And again, what about this ordinate?
Point
0.3. Here, one logic you have to understand is that while considering the slope, don't consider total length of the beam. That is 3 plus 10, don't consider 13. Just consider the span between the supports that you are considering. So the span between the supports is in between these two. Always remember this point. Not even in a hurry, do not consider 30.
Okay.
Suppose, again, can I draw ILD exactly at support A?
You can try,
Can I
sir.
draw ILD of shear force at point A?
Yes, sir. Can.
How many of you guys will agree that I can draw shear force at point A? Again, I am telling you, wherever there are changes, wherever there are changes in the magnitude, even you can say at point A, reaction will develop, isn't it? Because of that reaction also, there will be an abrupt change in the shear force diagram. Wherever there will be an abrupt change in the shear force diagram, at that point we cannot define the shear force. Or blindly I'm saying, wherever there is a concentrated force, wherever there are reactions, we cannot define the shear force. Similarly, as I'm telling you that, as at point A reaction forces will develop, we cannot draw ILD for shear force exactly at that point A. So instead, what we will say is that we will just say just to the right of point A. Now I am drawing ILD for right of point A. Imagine ILD for right of point A. Just for the clarity, I am just drawing the diagram here. Can you look at the point that I have represented just to the point A? Can you? Let us say somewhere very, very near it. Can you tell me how the deflected shape will be? ILD to the right of ILD for shear force. Can you tell me how the diagram will look like? Follow the same concept.
Right side will be a triangle, sir. Upside triangle.
It will be simply this. What about this slope? 1 by 10 as total length is 10 meter. What about this 0.1? Sorry, 1 by 10 into 10, 1. Is it right or any other changes that would have to be done? Is it right or any other changes that will have to be done? At least can you guess, if you try it, are you gonna stop like this or you got some other curve?
We can.
Are you
I
getting
think
this?
it is.
You think it is the same, right?
I think I yes. Sir.
Now, let me rechange this, okay? Let me rephrase this diagram. It's just a matter of visualization that I'm doing here. This is the point A, and this is the point C that I'm looking about. And this distance is around 10 to the power of minus 90. Now, what is the ILD for shear force at this point? How it's going to look like? This section you have to move it upward. Left side part you have to move it to the downward. This is the part. This is the part. What about the slope? 1 by 10. What about this slope? 1 by 10. What about this slope? 1 by 10. What about this length then? 10 minus 10 to the power of minus 10. How much is it? Nearly 10. Then what about this ordinate? 1. What is the difference between these two? So as I'm telling you that just to the right of point A, you guys will think that only the right side part will be upward, but you will neglect the overhanging part. So wherever you are just drawing the shear force diagram just to the right or just to the left, if I enhance this diagram just like this 10 to the power of minus 10, then you can understand that because of this part, this will also tilt up.
Yes.
But as this magnitude is very, very small, this might not be visible. So that's why if you draw the ILD just to the right of part A, then in addition to this triangle, this part will also come into the picture. As I tell you, what is this slope? 1 by 10. What is this slope again? 1 by 10. And again, what is this slope? This slope is also nothing but a 1 by 10. And again, what about this ordinate? 0.3. Any doubt in this diagram, ideally for shear force to the right of point A. Only you will get doubt somewhere here, this part. So this is what you have to remember. Like we are speaking just to the right of A. We are not exactly finding at point A. We are talking about just to the right of A. Or you can think in a one more logic. How like that? If I do not draw this case, okay, imagine at point A, two connected members are there, right? Here I can say AC and AB. If this part is not tilting up, what is the slope of AC? If this part remains horizontal, what is the slope of part AC? Can I repeat it again?
Okay, sir.
Can you guys tell me where you guys have lost it, and I will continue from there. It's like one-way communication is going on. No, it's not right. So everybody, please tell me where you guys struck, and from that point we'll discuss briefly.
The slope.
Slope. At least this diagram till this diagram, it's right, isn't it?
Yes, sir.
I think that's fine for
Till
everybody.
that. Yes, sir. That
Okay.
everyone should say the same points, sir. I'm only
Now
speaking.
see. As I'm telling you, continuity should exist, isn't it?
Yes, sir.
As we are talking about an internal point in the beam, just like as we have discussed, the slope to the left side and right side should be. If I talk about point A, if you see at point A, if I talk about the members that are connected, member AC is there, member AB is also there, isn't it?
Yes, sir. Yes,
According to the continuity, can I say that slope of AC member must be equal to the slope of AB?
yes, sir.
Can I say this or not? Yes, I can, isn't it? Now, if in this case, after drawing the deflected shape like this, can you tell me what is the slope of AC? Is it in the original position or is it deflected anywhere? AC part is deflected. If I remain like this, is deflected or it is there in the original position?
Original.
It's not, as of now, we haven't done anything with the AC. It is there, it's as it is. So what is the slope there? If it is not deflected, then what is the slope? 0. What about the slope of AB? Can I say this is my slope of AB? Can you tell me what about this magnitude? 1 by 10?
Yes.
What about slope of AB? That I am getting it as a 1 by 10, that too clockwise. Are these two same?
No.
Then is this diagram correct? Continuity is not satisfying, isn't it? If I draw only like this, slope of AB is 1 by 10, slope of AC is 0. But according to the continuity, these must be same.
Yes.
As of now, do you guys agree with this point?
Yes, sir.
Right? To make the continuity, what must be the slope of AC?
1 by 10.
1 by 10. That too in the same direction, isn't it?
Yes, sir.
Instead of stopping this diagram here, what we should do, you have to rotate your member AC in which direction? As of the present case, in clockwise, you have to rotate in a clockwise direction with a magnitude of 1/10. So if I draw like this, how much it will be? 1/10. Now it's clear. At least you guys got an idea. If it's still not clear,
Yes,
let me
sir.
know. I will further explain. Don't worry. Don't take too much stress. Ask me questions. We'll discuss.
Sir, this topic is a bit difficult to follow, sir.
Yeah. What about in yesterday's class for reactions?
Yesterday, we understood, sir, but if we see again, it is a bit difficult to follow, sir.
But this diagram is okay. This diagram is okay. This diagram is okay.
Yes, sir.
Again, this is okay.
Yes, sir. Yes, sir.
Now, again, let me come to the joints. Okay. If you are considering a point in between the supports, you guys don't have any problem. Why? Because as I can tell you, in this case, you can directly visualize, isn't it? If this member is moved to the downward, then obviously you can know that this will tilt in the upward, right?
Yes, sir.
So you don't have any problem in this. You don't have any problem in this, isn't it?
No, sir. No problem.
Just respond so that we'll discuss where you guys are facing the difficulty.
Yes, sir. It is clear, sir. Up to this.
Up to this. Now the problem is, what if I consider shear force just to the right of A? Let us discuss shear force just to the right of A. Let us discuss shear force just to the left of A. Let us discuss shear force right of B. Let us discuss shear force left of B. Okay. Now, let us again come to the first case. Is it clear that we cannot or we should not draw shear force ILD for shear force exactly at point A? Do you guys agree this?
Yes, sir.
Why? Because as the reactions will develop, there will be an abrupt change in the shear force. That's why we cannot define at that point. You are clear with this, isn't it?
Yes, sir.
Now, imagine if I consider a point here. On right side part, we should tilt it upward. That you guys will agree. Forget about the left side part. And then you guys know that this is a deflected shape. As of now, no issues.
No, sir. No, sir.
And you know this slope is how much? 1/10. What about this? 1/10. Imagine this length is 3 meter, let us say 4 meter. Then what about this ordinate? 0.4. What about this ordinate? As we are considering just to the right of A, what about this total length? We can consider it as a 10. And again, what about this ordinate? 1. As of now, any problem, right?
Yes.
Right. Now come to here. As we are drawing the deflected shape by imagine, this is what is imagination, isn't it? You will imagine and then that's what you're drawing the deflected shape. Now, one point I have told you is that we have to release the force along that particular direction only, isn't it? That's what you guys will agree. If I'm drawing the shear force, we should release that force only. Remaining constraints will be there as it is. That means if you release the shear force, then rotation you are not releasing. Rotation continuity must exist. So wherever you are drawing the deflected shape, just try to understand the continuity requirement. As just like in this case, why the deflection at this point is 0? Tell me. Why the vertical deflection? Why you have not shown any deflected shape here? Deflected. What is the support? Roller support. If it is a roller support, you know that it won't allow any vertical deflection. That's why if you draw the deflected shape, here the magnitude will be 0. Just like in the same case, if I talk about joint A, I know that rotation in the member theta AC must be equal to rotation in the member theta AB. As I can see here, member AB is rotated with how much magnitude? Member AB is rotated with a magnitude of 1/10 in clockwise direction. To maintain the continuity, theta AC must also rotate by an amount 1/10. So rotate this amount by 1/10. Just like how much? Just like here. So whatever this magnitude, this is also 1/10. If this is 3 meter, we know that this is 0.3. Now somewhat is it clear?
Yes.
Now, without wasting time, let me take the simple diagram. Same thing. 7 meters, let us say, even though it is very high, 10 meter, 3 meter, A, B, C, D. What will be the ILD for shear force to the left of C? If I talk about left of C, you guys know one thing, right? Right side part you should move to the upward, left side part you would move to the downward. If you talk about left side, just to the left of point C, this part you should move it downward. If it is moved to the downward, how the deflected shape will look like? This. What about this slope here? 1/10. What about the slope here again? 1/10. What about this magnitude? Just to the left of C, then total length will be 10 meter. 10 into 1/10. This is also equal to 1. And what about this ordinate? 3 into 1/10, 0.3. Now, again, as we are talking, even though just nearer to the support, see, at joints, how many members are connected? Theta CB is connected, and also theta CD is also connected. To make the continuity requirement, theta CB must be equal to the theta CD. Now you can see, theta CB is rotated in which direction? If I want to find the slope, theta CB is rotated in which direction? It is rotated in clockwise direction.
Clockwise.
Clockwise, isn't it? Clockwise.
Sir, clockwise. Yes,
Clockwise
clockwise.
by amount 1/10. So if CB is rotated by an amount 1/10 clockwise direction, then CD must also rotate by an amount 1/10 in clockwise direction. That means this part I should draw. That means see, I have rotated in clockwise direction. What is the magnitude? 1/10. Then what about the magnitude here? 1/10 into 7, 0.7. Any doubt? These two diagrams are similar. Any doubts as of now?
Clear, sir.
Yeah, seriously? Ask me the questions, doesn't matter. Don't keep it with you. Take 2 minutes of time. Try to understand.
Sir, you can.
Yeah, please.
Sir, you can give any example. Then we can think about it. Because now this problem you have explained everything. So if you give me one more problem, we will try.
And one more thing here is that the more you practice, as I'm telling you, the more you face the type of problem that you're gonna understand. Let me see. We haven't completed this problem. What you guys can try? What is the ILD for shear force to the left of A? Try it and let me see. Draw the ILD for shear force just to the left of A. Diagrams are clear, right? The two diagrams, how they have drawn.
Yes, sir. This two diagram is clear. Right of A and the C.
Yeah, right of A and left of B, that's fine. Now try it for left of A and let me see. Make sure that what you should do, you should not forget the continuity requirement. If you're drawing for shear force, try to see the continuity requirement of slope. Always try to see the requirement of slope. That is where the most of the diagrams will lead us to correct answers. Meanwhile, if you guys are having any doubts, let me know. I will clarify your doubts.
Sir, if it is left of A means we have to consider the portion CA first, right, sir?
Yeah. So what I will do here, I will place this type of support just to the nearer to the A, vertical shear hinge. Can I place it?
Yes, sir, we can.
I place this. That means I'm releasing only the vertical force. I'm not releasing any other thing. Anybody have done?
Sir, three triangular is coming below reference lines for me.
Can you please send me a photo or tell me what about others? Anita, Pramya is left, Priyadarshini and Vishnu. Imagine if I move it to the upward. First of all, right side part should move to the upward, left side part should move to the downward, isn't it? If I try to move it to the downward, how the deflected shape will look like? If I try to move it to the downward, will the deflected shape will be like this, the left side part?
Yes, sir.
What about this support? See, it is a free thing, right? Free support. It can deflect, it can rotate, it can displace, anything can happen, isn't it? Instead, what will happen? Can't this simply move it to the downward, just like this? Imagine you have placed a vertical shear hinge there. If you pull it downward, can't it just simply slides down, part AC?
Probably. Sir.
Probably, right? Then if it simply slides down, what about the slope in the AC? It is a horizontal line. What is the slope? 0.
0.
AB is also a horizontal line. Then what is the slope? 0. So if it is, this is what nothing but ILD for shear force for left of A. How we have drawn the triangles here, that's I just want to see. Like here the point is wherever there is a free end, at that end we have to be careful. Instead, if there is a support like this, what do you think it's gonna deflect it? If there is a support like this, then it might gonna deflect like this.
Yes.
If as there is no support, this will simply slides down. Still in doubt? Guys, speak about it. It's not like we are trying the new cases. If you are not getting, that's completely fine. Why? Because you guys are trying it by your own. And then we have to rectify the mistake. I don't know exactly how you guys have drawn it, but this is the correct way of drawing. Why? Because as C is a pre-end, wherever there is a pre-end, we have to be a little bit careful. As if I try to move this to the downward, obviously what will happen? As C is the pre-end, don't you think just simply AC part will slides downward? Of course it is, right? If you have drawn in any other way, let me know and let me give you the suggestions why we cannot draw like that. Can you send me a photo through Teams? Through here. You can.
Sir, I didn't consider the free end. That's why I got a triangular shape.
Triangular
Now I
shape.
got a point. Yes, sir. Yes,
got
sir.
the point, right?
I didn't think about. Yes, sir.
Yeah.
I did a mistake in that area. That's why I made a 3 triangle.
No, that's
So
completely
I
fine.
understand.
Where it should not come the mistake. Now, what about ILD for just to the right of A for shear force? Sorry, right of B.
The same, like because of the same logic.
How it
D
will
is
be,
a free end.
isn't it?
Yes, sir.
So what we can understand from here, if the load is in between AC, then only the shear force will develop to the right of A. What about in other parts? If the load is somewhere here in any span, the shear force will not develop to the left of A. Shear force to the left of A will only develop if the load is in the portion CA. Isn't it? Is it right? What was the statement that I made?
Sir, if the load is in between A to B only, we are getting shear force diagram.
No. Where you are seeing the ordinate here in this diagram, where you are having the ordinates, this is what your ordinate, isn't it?
Yes, sir.
Your load is here, you are having some ordinate. If your load is here, you are having some ordinate. If your load is here, is there any ordinate here?
So slope only is 0, but ordinance is there. Okay.
Where is the ordinate? If the load is here, what is the ordinate? Can you tell me?
But A to B is 0 ordinate and 0 slope.
That means if your load in between A to D, there are no ordinates. That's why if your load is in between A to D, shear force to the left of A will not generate. Or if I remade the statement, shear force to the right of A, shear force to the left of A will generate if the load is in between the portion A to C. If the load is in between A to D, shear force will not develop to the left of A. If it's not clear, again we'll discuss this point. No worries about. Do you have any confusion as of now?
Yes, sir.
It doesn't matter even it is a very worst mistake or when it is a blunder, just let me know. We'll rectify it and we'll learn from it. What I'm saying is that imagine that if your load is moving here, let us say 10 kilonewton load is moving. What about the ordinate here? Can you tell me? 1,
1.
1, right? Now tell me, if the load is at 10 kilonewton, load is at C. If L means load, if the load is at C, what is the shear force to the right of A? Can you tell me?
So this is shear force at right of A 0, sir.
Sorry.
Right of A is 0.
I have drawn shear force for left of A. This is
Left
what
of
I
A
will
is 10 kilometer.
10, right?
Yes, sir. 10 kilometer.
If load is in between A to C, if
A
load is in
to
between A to C,
C.
what is the shear force to the left of A?
Same magnitude, 10 kilometer.
If the load crosses this point, if the load beyond A, then what is the shear force at left of A? Is there any ordinate here? No.
No, sir. 0 ordinate.
That means what we can conclude? If the load is in between the span A to C, then only shear force will develop to the left of point A. If the load is in between A to C, A to D, if the load is in between A to D, shear force to the left of A will be 0. Now it's clear. Is it okay somewhat right now? If you guys want me to continue, we will, or we can stop here and go through the slides. We can continue in the next class also. Nobody is responding. What is the difficulty? I don't know. Yeah, Vishnu, I understood. The only way of understanding is to ask questions. Andal is asking some questions. That's good. We will learn from it only. I am ready to explain even 1 plus 2 is equal to 3. But you should not ask, you should know, you have to ask the doubts. Then only we will learn. This is a difficult topic that I definitely agree. That is where we will give our full potential in the class itself, and we should try to learn. That is what the primary motive of the class. Not unlike our BTech regular classes, they will teach and we will learn after we went home by ourselves. That's not how this class what's meant to be. That's what I'm trying to. As of now, at least, as you guys are trying this for the first time, I'm pretty sure that you guys will. This yesterday recording we can also. What do you guys think? Can I stop and will you go through the recordings of these two classes and shall we continue from the next class? Or if you want to ask doubts here,
Sir,
then
once
we will-
again, can you come from the first?
Yes, please, Ramya. I think your voice is interrupted. I could not able to hear completely. There is only one thing. If you are talking about influence line diagram, as of now for the determinate structures, what we have to do is that do only one thing, that is release the force and apply unit displacement. Here you have to understand one thing, that is you have to release the force that you are going to draw ILD for. If you want to draw ILD for shear force, you have to release the shear force. If you want to draw the ILD for reaction, you have to release that reaction. Once if you release that reaction, then only at that point it's try to deflect it. So that is what the concept of Muller-Breslau principle, that whatever the ILD that you want to draw, release that force, apply the unit displacement and draw the deflected shape of the system, structural, draw the deflected shape of the structure. That is what nothing but your influence line diagram for that quantity. Here, if I am talking about ILD for shear force to the left of A, once again I'm telling you, I'm not telling at A because at A reaction force will develop. There will be abrupt change in the shear force diagram. That means there won't be any continuity. That's why wherever there are reactions or wherever there are concentrated forces, we will not draw shear ILD for shear force because shear force cannot be defined at that point. That's why wherever there is a support, what we will do is that we will draw just to the left of that support or we will draw just to the right of that support. As in this case, if I want to draw to the left of A, I want to release that force only. If I want to release the shear force only, for that I will replace with this type of support. So this supports implies that it will release only the force in this vertical direction, but it will still maintain the continuity requirement for rotation and also for the axial force. As this joint is a free end, if I try to pull this in the downward direction, this entire beam will slides down by an magnitude 1. As if you talk about the continuity of the slope, as this is still horizontal, the slope is 0, and here also the slope is 0. So this is what we will say the ILD for shear force to the left of A. Can I give you a simple problem? Determinate or indeterminate?
Indeterminate, sir.
Which one?
Indeterminate.
It is determinate then.
Indeterminate.
It is determined now.
Now, as of now, we have done shear force and reaction. Can you please draw ILD for vertical reaction at A, vertical reaction at C, shear force to the right of A, shear force to the left of C, shear force to the right of. Can you take this as a homework and can you please come tomorrow and we will discuss and then we will continue for ILDs for bending moment. Can you
Okay,
please do this as an exercise and so that it will be much clearer?
we will try, sir.
As of now, for today's class, if you guys have any doubts, let me know, or else we'll meet us on Friday. As we are having the long gap Wednesday and Thursday, guys, please try to at least go through whatever we have discussed. That's it. Yes, please.
The last text, share force at right of C, sir.
Right of C, yes.
Okay, sir.
Shear force to the right of C.
So vertical reaction at A, vertical reaction at C,
Yeah.
shear force at right of A, then shear force at left of C and right of C.
Yes, right.
We will try, sir.
So that side is 1, 2, 3, 4, 5, then it will be much clearer. Okay. So shall we wind up today? Only the thing why I'm winding this today is that to give you some time. I don't want to burden again everything on you. So if you prepare, then it will be a good flow then again. Do not try to, don't miss the class. If you miss the class, try to see the recording and come to the next class so that you will not discontinue it from whatever I teach. That's what the request from my side. If we don't have any further queries, can stop it now. If you guys want me to share the slides, I can share it with you. Or else it's fine.
We'll try with this, sir.
Try this. See, one more thing. Even if you commit it wrong, no issues. Doesn't matter. I'm telling you, this is your learning stage only. Nobody will get it much easily. You have to solve a lot of problems, then only you will end up in correct way. Don't expect that, unlike the other subjects, I by heart the formula and then I can get the reactions or I can get the expected answers. No, you won't. Sorry. Okay, cool then. Shall we
Yes,
stop
sir.
here?
Yes, sir.
I think you four
Yes, sir.
clearly at least happy that you guys are interested in something. Okay. Thank you. If you guys need any help, you can always message me, WhatsApp me. That's completely fine. No issues. Even if you have any doubts, you can message me before to the next class. It's completely fine. Okay. Okay. See you. See you on Friday. Tomorrow I won't able to
Thank you,
take
sir.
that. See you on Friday. Meanwhile, draw this and send it to me. I'll check it and let you know. Okay.
Okay, sir. Thank you.
Yes.
Okay,
Thank
then cool. Thank you guys. Thank you.